all, in this video I am going to explain vulnerabilities in InsecureBank version 2 Android tab and how we are going to fix those vulnerabilities. InsecureBank version 2 Android application is made for security professionals and developers to learn the Android insecurities by testing this vulnerable application. So its backend server component is written in Python and it is compatible with Python 2. The client component, that means Android InsecureBank APK, can be downloaded along with the source, and the size of the APK is 3.3. The creator of this application provides a detailed guide on their GitHub account about how to set up the application and its backend server. For this article, I use Kali Linux virtual machine as my host device and Google Nexus 7 emulator created with Genymotion as my testing device. And here I also configured both virtual machines to use that and host on with adapters. Okay, so this is how the InsecureBank version 2 apps look like. So, to identify the potential vulnerabilities, I use security-related open source testing tools. Here I used both black box and white box testing tools such as MobSap testing tool, and then I used ImmuniWeb, and then I used Quixi mobile app vulnerable test tool, and then I use this BWiki tool, and then I use Androbug frameworks, and then I used Mara framework as well. So the list of vulnerabilities that I found using those tools are flood broadcast receivers, intent sniffing and injection, weak authorization mechanisms, local encryption issues, root detection and bypass, and insecure content provider access, and insecure web view implementation. And those are the some of the vulnerabilities that I found using this analysis. But for this video, I am choosing only 8 vulnerabilities and trying to fix them as well. So the first vulnerability that I found is weak cryptography implementation. As you know, using weak algorithms, it allows an attackers to break the ciphered communication, gaining access to plain text content. Even in the face of an attack, cryptography is supposed to maintain the data secrecy, integrity and validity. But in this mobile application, there you can see ZZHL and ZZA Java files inside this sources folder, inside this sources folder. And there you can see they used MD5 algorithm. Unfortunately, MD5 has been cryptographically broken and considered insecure. For this reason, it should not be used for anything. Instead, developers should switch to the secure hash algorithm, or they can use a symmetric cryptographic algorithm. So, with current GPUs and hash cracking tools, using MD5 is barely better than using nothing at all. Therefore, we have to use cryptographic algorithms, or we have to use SHA-256 to avoid man-in-the-middle attacks. Okay. And the second vulnerability is non-parameterized SQL query. So, as you know, non-parameterized SQL queries make the application vulnerable to SQL injection, through which the attacker can inject malicious SQL statement to exfiltrate the data from the database. In this mobile application also, there you can see inside this ZZJ Java file, inside the sources folder, there you can see they use non-parameterized SQL query. So mitigate this vulnerability, what we have to do is we have to always use parameterized queries for avoiding such SQL injections. And the third vulnerability that I found is sensitive information in logs. So as you know, sensitive information in logs may expose data to potential attackers and compromise privacy of stakeholders. In this mobile application, there you can see inside this do login Java file, inside this resources folder, here they keep the password keep the username and the password inside this log file. So this is a critical vulnerability and allows attackers to exposing any sensitive information the user may supply. To mitigate this vulnerability, what you have to do is do not log sensitive information like credentials, IP addresses inside our log files. And the fourth vulnerability is storage of sensitive information in shared preferences. So you know anyone with root access to the device will be able to read the information stored in shared preferences. Hence can potentially compromise the sensitive information. To mitigate this vulnerability, either do not store sensitive information in shared preferences or else we can use the encrypted shared preferences class that can be used instead. The fifth vulnerability is unencrypted SQL database. So malicious program with root access to the mobile device or attacker with physical access to the device might both access to this database. An attacker who gains access to the SQL database that is not encrypted can view sensitive data that is stored within the database. To mitigate this vulnerability, uh, we have to sensitive data shouldn't be kept in the application clear text database. So therefore we can use SQLDB encryption extension, that is SQL Cipher is a SQL extension that provides transparent 256-bit AES encryption of database files. And the next vulnerability is use of implicit intent for broadcast. So the application that send broadcast without specifying the broadcast target that may have these broadcasts intercepted by malicious act on the same devices. Here as you can see. So to mitigate this vulnerability, we can use exit for IPC, and if the intent is only broadcast or received in the same application, we can use local broadcast manager as well. And as the recommendation, we can adapt secure coding practices and using coding standards that address security issues, or else we can conduct regular code reviews that involves multiple team members and use static analysis to catch vulnerability easily, or we can follow secure software development life cycle that incorporates security at each stage of the development process, or else we can implement threat modeling to identify potential security risks and vulnerabilities early on in the development phase as well. Okay, so that's all. Thank you and have a good day.